Well, good morning and welcome back. And we are going to talk today about measuring angles. And again, this is a complement to measuring lengths and cutting the section in half to where we could focus on lengths in one lesson, focus on angles in another. So as we look at this, we're going to talk about how can you find the measures of angles. And we're going to end up getting to an angle addition postulate like we got to a segment addition postulate, but let's begin with angle measures. And here we have acute, obtuse, right, straight, and reflex angles are classified because of their degree measure. Okay? It depends on the amount of degrees of an angle in order to find out what that angle measure is. And here, the space inside, right here, this space in here is the degree measure. How wide is that opening? That is the degree measure. Here, how wide is the opening between the two sides of my angle? How wide is the opening between the two sides of my angle? And again, over here, how wide is the opening of the sides of my angle? So as I look at this, I should be able to look at this and say, this one right here, that's a right angle. It's 90 degrees. The measurement of my is going to be 90 degrees, so that makes it a right angle. I should be able to pick up this one too, that I have a straight line, so therefore I have a straight angle, which we know is 180 degrees. I don't know the degree measures necessarily on this one and this one, but I can tell you that this is less than 90 degrees, so that makes it an acute angle. This one seems to be greater than 90 degrees, so that makes that an obtuse angle. So looking at our angle measures, that's our first start. And up until now, you should be familiar with those, but this reflex angle is going to be something different. Reflex. And what it is, it's an angle greater than 180. So if we look at this right here, we're starting here and we're going, the angle is not in here, it's out here. So this would have been approximately 90 degrees, then we come over here to approximately 180 degrees, but we keep going beyond that 180 degrees to right here. So it's greater than 180 degrees, but less than a complete circle, which is 360 degrees. So that is my reflex angle. Now continuing on, as we talk about these angles, we're going to talk about adjacent angles. And adjacent angles are angles that are next to. So here if I look, angle JHK, this angle right here, and I'm just going to shade in the inside of it. So this angle, right, JHK, and GHK, I always hate when I put blue and red next to each other because you just never know what you're going to get. And so that angle right there, they are adjacent angles. And they're adjacent angles because they are next to each other, and if you notice, they have a vertex of H, so they both share H, and HK and ray HK in common. So they share vertex H and have HK in common, and they do not overlap. They are just simply next to each other, and they are adjacent. Let's get rid of that. Okay, so there we go. Those two angles are next to each other and adjacent. Looking at that, now we talk about that angle addition postulate. Just like when we had segments which were connected, we now have angles that are going to be connected because they share a common side. We have the measure of an angle created by two adjacent angles is equal to the sum of the measures of the individual angles. And then, so what are they saying here with this statement? They're saying that if I add the measurement of this angle to the measurement of this angle, it should be equal to the measurement of the whole thing. So let's see, I have angle JHK plus angle KHG is going to be equal to the sum of the measurements of the individual angles, which would be equal to the measurement of angle JHG. So doing some substitution here, I can tell you that JHK right here is 22 degrees, plus KHG is 130 degrees, and that is going to be equal to, well, when I add those two things together, I get 152 degrees. So angle JHG is equal to 152 degrees. There you go. Doing some substitution, I created the sentence. The measure of two adjacent angles is equal to the sum of the measures of the individual angles. So there you go. So these two added together equal the larger angle. So we go ahead and apply that definition here in number 1, that angle ABD is 48 degrees. 48 degrees, and DBC is 78 degrees. They want me to find ABC, so I know that angle ABD plus angle DBC is equal to angle ABC. Now, I know right now everybody just added those two things together and said, hey, it's going to be 126 degrees. But what I'm doing is I'm trying to build in the repetition of doing the equation and substituting, because it's going to get more challenging and we don't want to just forget why and how we're doing something. So again, do my substitution, 48 degrees plus the substitution of 78 degrees is going to be equal to 126 degrees. So angle ABC is equal to 126 degrees. Again, practice. We can't fast forward and not have practice. So that's why we created our equation based on our definition. We did some substitution and combined like terms and came up with an answer. So looking at number 2, it says if angle DBC is 74 and angle ABC is 119, what is ABD? Okay, well, what we can do, it looks like we're using the same letters. So if I have, if not, let me see, the measure of DBC. If this is D, this is B, and this is C, that's 74 degrees. And then it tells me that ABC, well, A is out here somewhere. I guess it doesn't mean that it's a straight line though, huh? We'll do this. I have ABC. The measurement of ABC is 119 degrees. So the distance from this side to this side is 119 degrees. The distance from this side to this side was 74 degrees. And what they're trying to figure out is they want to find what is the measurement from here to here. Okay, and let's just do our angle sum theorem. And we know that angle ABD plus angle DBC is equal to angle ABC. And if we do some substitution, so there's my definition, do some substitution. DBC right there is 74 degrees. ABD, currently unknown, ABD, because that's what we're trying to find. And it tells me that ABC is 119. And I can isolate, do some inverse operations. I can subtract 74 from this side. So I have to subtract 74 from that side. And I know that angle ABD is equal to 119 minus 74. Gosh, is that 45 degrees? There you go. Now, that seems like a lot of work to come up with something so simple. However, the practice of creating this equation, substituting, and finding an answer, it's all about practice, whereas it gets harder, it's easier for you to follow along what's going on. All right, so looking at example number 3 here, we have the measurement of PQR is 114 degrees. All right, so they're telling me that this measurement right there is 100 and, I'm sorry, I said 14. I meant 141 degrees. Now, if I look at that image, I know that this angle plus this angle equals the entire thing. So if I write that out using my angle addition, I have the angle of PQS plus the angle of SQR is going to be equal to the angle of PQR. So there's my definition, there's my equation, and if I do some substitution now, PQS is 13x plus 4. SQR is going to be 10x minus 1, and that is going to be equal to PQR, which they said is 141 degrees. They gave that to us right there. So now I'm in a position where I can just combine like terms. I know that I should be able to combine 13x and 10x for a total of 23x. I should be able to combine 4 and minus 1 is going to be plus 3 is equal to 141. Go ahead and subtract 3 from both sides so I can move that away and make it 0. So I have 23x is equal to 138. I'm going to divide both sides by the coefficient. A little bit excited there. Divide both sides by the coefficient. So 23 divided by 23 becomes 1. So I have x. X is going to be equal to, I hope it's 6, right? 138 divided by 23 is going to be equal to 6. So there is the measure of x. Now that doesn't tell me each measure. In order to find out each measure, I can substitute in here. 13 times 6 plus 4 equals 78 plus 4 is 82 degrees. And then here I have 10 times 6 minus 1 equals 59 degrees. And when I add those two things together, sure enough, they would have equaled 141 degrees. So there you go. I was able to come up with that information just by doing some substitution. Now, as we continue with these angles, remember, we're going to talk here, I guess, remember what we talked about before as we move forward. Angle bisector. Angle bisector is an angle bisector divides an angle into two congruent angles. Remember that the word bisect in geometry means to cut in half, right? So that's why we're making two congruent pieces of a whole. So here, as we can see that, looking at this, I have angle ABC, and it is bisected by BD because it cut that in half because ABD is equal to DBC. So that is an angle bisector. Here is my angle bisector because it cut it in half. Here my angle bisector is going to be segment ZP because I have 90 degrees over here, I have 90 degrees over here, so it bisected angle JPL. And right here we don't have any measurements in this example. However, I can see that I have a large angle. The whole angle is NMP right here, and it is being bisected or cut in half by QM because MNQ and QMP are going to be equal. So there is my segment bisector there, cutting those segments in half. So there we have it, and we'll look some examples here. So if all right, so let's just see here. Segment BD bisects CBE. So this segment, that ray is my bisector, and it bisects CBE, so that means that this piece and this piece are going to be congruent. And it tells me that CBD is going to be 8x minus 25 degrees. And it says that CBD is going to be 9x plus 34 degrees. Find DBE. Okay, well, let's see here, some substitution. I know that looking at this equation, I know that angle CBD is congruent to angle DBE because it was bisected and these two pieces are equal. So if they are equal, then I know that if CBD is equal to 8x minus 25, then DBE is equal to the same. So I know that this is also 8x minus 25 degrees. So looking at that, I know that, just did a little bit of calculations there. I know that angle CBD plus angle DBE is equal to the larger angle of CBE. So now I'm in a position that I can do some substitution. So we said that CBD is equal to 8x minus 25. DBE we said was also equal to the same, 8x minus 25. And then that is equal to the larger angle, which we said is 9x plus 34, right there. So now I can go ahead and combine like terms. I have 16x minus 50 is equal to 9x plus 34. Can do some inverse operations. Let's see, if I go ahead and I add 50 to both sides, so I can get my numbers together, that becomes 0. I have 16x is equal to 9x plus 84. I'm going to go ahead and subtract 9x from both sides so I can get my variables together. 9x minus 9x equals 0, so I have 84, I have 7x. 7x equals 84, divide by 7. And then turns out that x is going to be equal to, has anybody done the math yet? X is equal to 12. Can't remember, did they ask me to find x? Nope. They said, what in the heck is DBE? Well, I know that DBE is equal to angle DBE is equal to 8x minus 25. So 8 times 12 minus 25 is going to be equal to, hopefully everybody got 71 degrees. So there you go. That is the angle of DBE. Okay, so again, creating that definition, we may have been a little bit ahead of ourselves when we came up with this information, but it did help us over here. So it's really just sort of gathering the information, putting it together, and seeing what you need, what you have, and what is useful. Okay, so here it says that the measurement, example number 5, if the measurement of AED is 132 degrees, what is the degree measure of the smallest angle of the diagram? Okay, I don't know what the angle measurements are yet because they are all in variable form. There's a variable in all of them. But I do know that this entire angle, the entire thing here, is going to be equal to 132 degrees because that's what they gave me. So let's see here. I know that, let's see, if I do that segment addition, I know that angle, sorry, didn't mean to do that again. I know that angle AEC plus angle CEB plus angle BED is going to be equal to angle AED. Okay? This angle plus this angle plus this angle equals this big angle. That's my angle addition postulate. Now I can just do some substitution. Okay? I have AEC, which is 3x plus 4, plus BC CEB, sorry, 5x plus BED, which is 2x plus 8, and that is going to be equal to 132 degrees. So now I'm in a position that I can solve for x by doing some inverse operations, doing some combining like terms. So if I combine all my numbers, I have 12. If I combine all my variables, it looks like I have a few. So let's see here. I know that I have 12 is equal to 132, but 8 plus 4 is 12. And then I have 3x plus 5x plus 2x. That is going to be 10x. So now I've just simplified my equation, and it's much easier to work with now. So I go ahead and subtract 12 from both sides. 12 minus 12 is 0. I have 10x is equal to 120 degrees. Divide both sides by the coefficient, and x is going to be equal to 12. Now, that doesn't help me right now because I need to find out what the angle measurements are, but in order to find out what the angle measurements are, I can just substitute. Substitute 12 in for x, and then it might tell me what are my angle measurements. So here I have 3 times 12 plus 4 is going to be 36 plus 4, which is 40 degrees. Here I have 5 times 12, which is equal to 60 degrees. And then over here I have 2 times 12 plus 8 is equal to 24 plus 8 is 32 degrees. So there we go. Those are my angle measurements. What is the smallest angle? And the smallest angle is this one right here. What is the degree measure of the smallest angle in the diagram? And the answer is 32 degrees. So there you have it. From here to here is 32 degrees. And there you go. There you have it. So we've done some angles, some angle addition postulate. We've done some practical examples, and hopefully these will help you with today's assignment.